the science. This is the New York Times, Science Times, and in the Science Times, an amazing story about a um, a rocket that was sent to outer space by the Japanese people. Um, Japan sent a rocket to an asteroid, um, 3 billion miles away. Um, what is an asteroid? An asteroid is a big piece of rock in space. Good morning. Good morning. A big piece of rock in space, and they sent the rocket. The rocket landed on this piece of rock, right? And that's pretty amazing right there, because how do you find this piece of rock out there in the wilderness of space, 3 billion miles away? Um, and it not only landed on the rock, but it grabbed a sample of the rock. It took a little bit of that huge rock, which was a half a mile across. It took a little bit of the that rock was made of, and it it brought it back to the earth. It brought it back to the earth, and now scientists are eagerly awaiting to see what that asteroid is made of, because they believe the asteroid was um, present at the beginning when our solar system was forming.
Hi, beautiful Barry.
Hi, some more folks are coming in. So
This is Frank.
Frank and the lady next.
Liza. You remember me, Liza?
Liza, good morning, dear.
Good morning.
How are you?
Frank is been on vacation.
Great to see you.
Yeah.
What is the lady's name next to Frank?
What's your name? Christina.
Christina. Yes. Hi. How are you? It's been a long time since I've seen you.
You're beautiful.
Thank you.
I see you a little bit.
Good to see you, Liza, and everybody. Um, so I was just talking about, for the folks who just came in, I was just talking about this amazing thing that happened out in space, where the Japanese sent a rocket to an asteroid. An asteroid is a huge piece of rock, in this case, that was formed in the beginning when our solar system was formed. So this asteroid is very old. It's 4.5 billion years old. And scientists think that it might have clues to the origins of life. It might have be made of stuff that led to the formation of life. And that's why the Japanese sent a rocket there to pick up a sample of this asteroid. They actually this machine dug into the asteroid and took a sample of the rock and um, put it inside a rocket, and the rocket came back to the Earth and landed in Australia. And now scientists are going to look at what that sample of the asteroid is and determine whether or not it tells us anything about the origins of the Earth and maybe even of life. Sometimes in space we find certain chemicals and certain molecules that have to do with how life is put together, like amino acids, for example, water, for example. We find these things in space, and they are clues that tell us that the universe itself is generating the stuff necessary for life. How incredible is that? And so today we have the means of exploring the universe such as we've never had before. And this is really quite remarkable. You know, 100 years ago, we didn't have rockets. We barely had airplanes. And now we can go to different planets. We can send our rockets out past the planets. We can look into space as never before. We have a space telescope, right? You know, you've heard of the space telescope, perhaps. And the space telescope has been operating since the 90s and giving us a wonderful view of the universe such as we haven't really seen before. So we live in a remarkable time. We can look into the large and we can look into the small. We have the ways of looking at the tiniest of things down to atoms and molecules. And so we're really we're really moving in a direction that allows us to understand the universe. Any questions or comments? Okay, I'm gonna have a drink of coffee. um, Now, coffee is a wonderful thing. Coffee comes from a certain tree, right? And it's a flowering tree. About 140 million years ago, the first flowering trees appeared on the earth. This was a revolution that changed the world and made it possible for most of the things that we eat to be in the world. But I'm not going to talk about that right now. I have, and so the coffee in your cup is a development of the flowering plants. It's the world has had many revolutionary developments, many changes in its living in its life forms. We used to have dinosaurs walking around in the streets, even before there were streets, right? And now we don't have any more dinosaurs, but we do have the birds, which were part of the dinosaurs that survived to this day. Every bird is a dinosaur. Is that amazing or what? That is amazing, right? Every bird is a dinosaur. Um, here's a book. Here's a book called The Hidden Reality. I don't know if you can see this. The Hidden Reality, and it's by a scientist, Brian Greene. And it talks about how things are hidden from us. He's a physicist or a cosmologist, whatever that means. Cosmologist who studies the universe, and most of the world is hidden to us, right? If you look out into the night sky, you will see a few stars. If you live in a dark place, you will see some more stars. Generally, if you live in a good dark place, you can see a couple of thousand stars. But there are more stars than grains of sand on the beaches of the world. That's hard to imagine, isn't it? There are more stars than grains of sand on the beaches of the world. I find that very difficult to comprehend, to understand. And yet the science tells us that it's so, and which means that somewhere out there are a lot of stars. And now we know that there are lots of planets as well. We didn't know that there were other planets outside of our own solar system till a few years ago. Is this news to you that there are other planets circling other stars? Have you heard of this before? You know, every star is in the sky is like a sun. Every star out there is like a sun, and it may have a planet or two or three or even more going around it. We have our telescopes now, which are so sensitive that they can detect the movement of planets around other stars. And this was only possible a few years ago, when somebody developed a way of looking at stars and telling us and be able and detecting whether the star dimmed very slightly again and again over a period of time. And what we saw in that dimming was a planet that moved across the face of that star, causing the light to dim. And that's how we detected the first planets around other stars. And now we have detected thousands of planets around different stars. And it's quite amazing. But you would think that why not? Why shouldn't there be planets around other stars? Are we the only ones in the universe that should have planets? Why? If there are so many stars, why shouldn't planets be around those stars as well as ours? You know, we have our sun is of course a star, right? And we have 8 planets that formed around in our neighborhood, around our sun about 4.5 billion years ago, along with asteroids and comets and space dust and all sorts of things. And our planet is unique in our solar system of 8 other planets. We used to have 9, right? We used to have Pluto, but they say Pluto is not big enough to be a planet, and doesn't follow the right orbit to be a planet. So Pluto is now a planetoid. A planetoid. We say it in Brooklyn. Planetoid. So we have the other planets. Which are the other planets? Mercury, Venus, then there's the Earth, then there's Mars, Jupiter, Saturn, Uranus, Neptune. There used to be Pluto, but no more. Anyway, that's showbiz. And we have our planets which formed at the same time as our sun, and but we know that the other stars that we see also have planets around them now, which means that they could have life. The other planets out there somewhere in space could have life. Why? Because the 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 chemistry and the physics are the same everywhere you go. So if you have a planet around another star, you might have water on that planet. You might have oxygen. You might have nitrogen. Um, it depends, but it is possible. You might even have life. So that's exciting, isn't it? What if we discovered life on other worlds? Hmm? What would that life look like? Right? Would it be intelligent life? Would they have cities? Would they have science? Would they have religion? Um, these are interesting questions, no? Um, would they want to talk to us? Um, some people think that there are signs that we have visitors from other worlds right here today, now, right? Have you read about flying saucers and things like that? Now, people, you're laughing, but that's how the usual response people have. We laugh when we hear about flying saucers. Yet, some people think this is a serious subject, and some people in the military apparently think it's so serious they don't want to talk about it. How's that? There's a famous story about what is it? Oh, oh, what was it? I can't remember the names right now. um, uh, it'll come back to me, and I'll tell you maybe later if I can remember the names. So I can't. I'm getting older. I can't remember names anymore. Anyway, you're getting older too. Oh no.
You see?
Are we getting older or what? I mean,
You still look good.
it's beautiful, right? What? Did you say it's beautiful? Yeah, yes. There's some wonderful things that come with being older, you know, besides getting on the bus for a nickel or something. Um, you have grandchildren? Who has grandchildren?
I have
You
grandchildren.
do.
I have great also.
Great grandchildren? Wow. Wow. So, yeah, when you get older, it's nice to have grandchildren. Um, we just had our first grandchild come to us, and we're excited about that. But anyway, getting older, you know, has its rewards, right? Maybe you don't get so excited about certain things anymore. You don't get so bothered by certain things. Um, anyway, um, you can appreciate perhaps certain things as you get older, right? You can appreciate certain things. Like it's, you know, wonderful to have the sun on your face and breathe in the air and have a cup of coffee, and you know, it's just the little things become more more appreciated, I think. Um, and they're not so little, you know. The world around us, which seems ordinary, is quite extraordinary. Everything around us, which we take mostly for granted, like the air we're breathing, is really an extraordinary thing. The oxygen that we breathe, which is necessary for life, was made by life. Right? The plants of the world made the oxygen for us to breathe. How incredible is that? Every breath we take has oxygen that came from plants that made that oxygen for us even millions of years ago. I shouldn't say they make the oxygen. They release the oxygen from water and carbon dioxide in the air. When they make their food, they put together carbon dioxide and they take water apart, and when they take the water apart, part of the water is oxygen, and they release that oxygen into the air. Incredible, isn't it? I mean, what if it didn't work that way? We wouldn't be here. You know, one of the most basic things of life is the air we breathe. And that is connected to life itself. When the earth formed 4.5 billion years ago, we know, when the earth formed, it didn't have much oxygen on it, as we can tell. You can tell if you go into the rocks and you go deep into the rocks where the earth is older, and you don't see much oxygen or evidence of oxygen there. Oxygen only comes about gradually over time after life appears. The earliest life was simple life, and I say simple when it's not really simple, but we'll call it simple. The first life on the earth was bacteria. And let me see, I have a wonderful book here. Oh, there's this book is, this book is so heavy. This is called Natural History, and it's a great book. It's a great book to work out with. You know, you can lift it up and you get stronger. But it has all these wonderful drawings and paintings of living forms, and here's snakes and things. You know, everybody likes snakes, and you know, what's this? A platypus. A platypus. Here's a platypus. There it is. Platypus. The platypus is a very interesting creature. I'll get to the bacteria in a minute. But the platypus lives in Australia and is a mammal, which means it gives milk. It has fur. It's warm-blooded, and it also lays eggs. So it's very strange for a mammal to lay eggs, right? Mammals don't usually lay eggs, but this is a mammal that goes way back in time. And way back in time, mammals laid eggs. Then they developed a different way of reproduction, which depends on internal reproduction. And that's been the standard ever since. But way back, a long time ago, mammals laid eggs, just like the dinosaurs. Because both the dinosaurs and the mammals came from another form of life that laid eggs. So there you have it. But anyway, that's just a side note into the strangeness of life. Anyway, the bacteria is, here we have the bacteria was one of the early forms of life. And here we have all kinds of bacteria. And most of the time we think bacteria are bad, but that's not true because we have bacteria inside of us that enable us to digest our food, and they even may make vitamins for us and do other things that help the immune system and communicate all sorts of messages to us about what's going on inside us. And so we live with a community of bacteria inside of us. And that's okay because they help us. And so bacteria aren't necessarily bad. Some are bad, but not all of them. And so bacteria were the earliest forms of life that we know of. Already that was very complex because it had DNA. What's DNA? It's a code, the code of life, DNA. This code of life tells life how to become a bacteria or a mouse or an alligator or a human being. Each of us have this code of life in our cells. Every cell in the body that we have, mostly every cell has this little thread of information that's about, it's all wound up very close together, but if you can stretch it out, it's be about 6 feet long in every cell of the body. And this little thread of information tells the body how to create proteins. And the proteins are the structure of the body. The bones are made of proteins, the lungs, the liver, the skin, the eyes, everything is made of protein. And in our cells, there is a code that tells the body how to make the proteins. Now that's pretty amazing, isn't it? Where did that come from? We don't know. Nobody knows how that came about. There's so many mysteries about the body. Nobody knows how the intricate way that we take in food and break down that food and make energy out of that food. Nobody knows how that came about. It's very complicated. There's about 30 different steps. When you have a piece of toast, for example, there's about 30 different steps until you get to a place where that food is made into something that the body can use for energy and for building up the body. And so the body is very, very complicated, and we don't know how that came about. You know, so it's one of the great hidden mysteries. Also, we don't know why evolution takes place. What is evolution? Evolution is going from one type of life to another. How incredible is that? In the beginning, there were no trees and no plants and no animals, no birds, no fish, nothing like that. Just tiny little cells, right, floating around in the water. Nothing on land. If you looked out on land, you'd see a barren, rocky landscape for miles and miles with no trees or no plants. You'd need a microscope. You might have some things like bacteria growing on rocks, perhaps. But you need a microscope to see that. And so if you looked out, if you came to the Earth 4 billion years ago, and you looked around, you would say, if you came from another planet, you would look around, you'd say, there's nothing happening here. But if you took a microscope and a little sample of the waters, you would find that it was full of bacteria. But that's it. So how did we arrive when there was only bacteria? How do you make a human being out of bacteria? You can't. So we are wonders walking around along with birds and fish and insects and mice and, maybe not mice, but flowers and trees, all the things that we could see, the mice too, all the things that we could see came from bacteria. How is that possible? What happened to bacteria that made it possible for other forms of life to come about? And that is one of the great wonders that we've discovered in the last 100 years, that about 2 billion years ago, after bacteria had been on the planet and, bouncing around for a long time, suddenly a new type of cell appeared. A new type of cell that was bigger than a bacteria, that had much more information inside of it, that had a different kind of outside, and could generate a lot of energy, unlike a bacteria, and it had a lot of properties that were advanced, and that led to the world of today. That new type of cell led to all the plants and animals that we see around us today. And it took 2 billion years for that cell to come about. And yet it did. But once it did, it opened the doorway for new possibilities. So life is pretty amazing, right? I mean, we're sitting here, we have been the receivers of the changes that have taken place, and some of these have been huge changes in the thread of life, in the movement of life towards larger forms. Remember, you couldn't even see life in the beginning, and it took this new kind of cell to come about to create life that you could see, and also life that had were multicellular. Now, bacteria live in association to each other. They can live in mats, in also like what do they call that? Oh, I forget. There's a it's like a skin of bacteria. You find it on rocks. You find it on our teeth. We have bacteria that form a certain skin on our teeth. You might say there's another word for it. I can't remember. But the bacteria, we have bacteria in our mouths and all over our bodies. But the ones in our mouths are very interesting because there may be 100 different kinds of bacteria in our mouths, and they all form this kind of a skin on our teeth, which is why it's important to brush your teeth. They form this kind of skin, and they have like a communication with each other. They know where to go. The different kinds of bacteria go to the same place all the time. So if you brush your teeth, the bacteria come back to the same place as before. So you might get 2 or 3 different kinds of bacteria, and they know where to go. Isn't that interesting? Anyway, the bacteria changed into something different and allowed life to come forward. It allowed life to form multicellular organisms where we have different kinds of cells doing different jobs. The bacteria don't do that per se. They have differences, but they do the same job. But you can't have a bacteria become a mouse because there's no bone cells, there's no liver cells, there's no lung cells. And this is what happened after this development of a new type of cell that gave the possibility of an animal or a plant that would have different kinds of cells in it, like we do. We have 200 different kinds of cells, right? We have all sorts of liver cells and lung and kidney and blood and nerve and bone and what else? Eye cells. You know, the eye is an amazing thing. The eye cells have the property of letting in light, and that's pretty incredible. Anyway, we have all these different kinds of cells that work together that make us who we are. And that couldn't possibly happen when there was only bacteria on the earth. When there were only. Okay. Any questions? All right. Here's my cup of coffee. Now, in this coffee, what do we have? We have coffee beans, right? Ground up coffee beans and water. And we have milk in this one and cream, half and half. So you have all these different things which we take as ordinary things, but really, when you think about it, we have the water, which is a miracle in itself, right? Why should there be water? Water is made of what? Hydrogen and oxygen. These are two gases. And if you filled a room with these two gases, right, and you lit a match, what would happen? Oh boy, you wouldn't know what would happen, because there would be this explosion that would annihilate everything. But this hydrogen and oxygen, strangely, when it comes together, it makes water, which if you stick a match in water, what happens? It goes out, right? But it's made of the same stuff that if they were separate and you lit a match, wow. So it's interesting that atoms like hydrogen and oxygen have this ability to come together and form something completely new and different. And one of those things happens to be water, which is essential for life. Without water, no life. Not even bacteria could live without water. And so life had to be there first before it formed on the earth. And we have abundant water on the earth, which is pretty much a miracle. If you look around the solar system, you don't see much water on other planets. And that's for various reasons. But we have abundant water, and that enables life to exist on the earth. It also enables the climate to be more moderate, because the water on the earth in the oceans regulates the heat that comes from the sun. Most of the heat from the sun is absorbed by the oceans of the world. And that helps the climate to maintain a kind of evenness. Without that, climate would be, our temperatures would be more extreme than they are. And it might even be impossible for life to exist. I don't know. But at any rate, the water on the earth helps to regulate the climate of the earth. So not only does it enable life to be here, but it enables us to live in a moderately, with moderate weather. And water is just one of the miracles of the world. It does so many amazing things. For example, if you have a glass of water sitting on a table and you come back next week, what happens? You'll probably find the glass empty, or maybe half empty. And where did that water go? Did it just disappear? In a sense, yes. In a sense, no. The water disappeared into the air. The actual hydrogen and oxygen, little bundles, little molecules, disappear into the air. And what happens to that water when it disappears into the air? It goes up, and eventually it might form a cloud. And that is a wonder of water, that it has this ability to come together in the sky and form a cloud, instead of just dispersing out into um, into being too thin to become a cloud. If you take most gases, if you take like helium, and which we use to fill balloons with, you take that gas and you let it out into the air, it gets thinner and thinner, and it wants to become dispersed. And water does that too, but then water has this ability to come back together and to form a cloud. And that's really amazing, because without that, we wouldn't have rain as we know it. All the water would stay up in the sky. And thank you. That was my mail just arrived. Anyway, more coffee, I think, has come in the mail. We get coffee in the mail. And anyway, water is one of the deep mysteries of the universe. And the way it works in so many different ways enables life to be, whether it's from the water that we need to surround ourselves and be in ourselves, to the water in trees, which moves up in the tree and doesn't separate and doesn't fall apart in the tree. It maintains a constant line of water moving up into the tree, and that's one of the properties of water, that it can hold together. It has enough strength between the molecules that it holds together in the tree. And that's what enables trees to grow so tall. And it's what enables the tree to have water reach all of its parts. Any questions? So maybe I'll read a poem now. And let's see. Oh, it's coming towards Christmas time. And here I have a lovely book on St. Francis, St. Francis of Assisi. And, we've named our city across the bay here, San Francisco, after St. Francis. So, St. Francis is very special to people in California. And, he was a very interesting fellow. He lived in the 1200s in Italy, and he was the son of quite a well-to-do merchant who was dealing in silks and things like that. And his father spent a lot of time in France. That's where his business was, and he called his baby Francisco, which means the Frenchman, because he loved France. His father loved France, and that became the name of his child. So Francisco, he grew up in Italy, and when he was in his teens, he decided that he would join the church and give up all his material wealth. And so he did, and he started preaching, and he developed a following. He had people coming to him to hear what he had to say about God and religion, and even without much training, apparently. He just sort of did this on his own. And he developed this group of people, this following that came around with him, and eventually he was introduced to the Pope, and eventually started his own um, monastery, which even today they exist, the Franciscans, and they were people who took a vow to poverty. One of Saint Francis's fundamental uh, ideas was that we should be not materialistic, and so he emphasized that, and he also was a great lover of nature. And Saint Francis, put the sacredness back into nature, and that was one of his great contributions, I think. He had a great reverence for the world, for the universe, and here is one of his most famous poems, um, where he says, "Be praised, my Lord, with all thy works, whatever they may be, our noble brother sun, especially, whose brightness makes the light by which we see. And he is fair and radiant, splendid and free, a likeness and a type most high of thee. Be praised, my Lord, of sister moon, and every star that thou hast formed to shine so clear from heaven afar. Be praised, my Lord, for brother wind and air, breezes and clouds, and weather foul or fair. To every one that breathes thou givest a share. Be praised, my Lord, to sister water, sure none is so useful, chaste and pure. Be praised, my Lord, for brother fire, whose light thou madest to illuminate the night, and he is fair and jolly and strong and bright. Be praised, my Lord, for Sister Earth, our mother, who nourishes and gives us food and fodder, and green grass and flowers of every color. So that's beautiful, I think. And Saint Francis really had a feeling for the world around him. And I think that's something that needs to be recaptured today. We've possibly become strangers in this world that we live in, strangers to the wonder of it. Every passing moment is a wonder. Every passing moment, the world is created right in front of us by the ways that atoms and molecules work together, and the cells of the body work, and water and light, without which there would be no life at all. And it's interesting how all these things come together to create this world. How we have the light which plants use to make their food. That is, one of the fundamental things about living things is that they respond to light, especially plants. And how amazing it is that plants actually take the light and use it to create their food. Isn't that something? And they use the water and the very air that is surrounding them to make sugar. How incredible, that a plant can make sugar out of light, air, and water. Scientists can't even do that. Scientists have not been able to duplicate what every leaf in the world can do. Pretty incredible, right? Any questions, my dears? But Saint Francis had a feeling about the world. It wasn't just something interesting to think about. It was something that he revered, that he um, that he thought of as sacred. Hmm? Everything to Saint Francis was a sacred reality. And that's the point I think he was trying to make. The point that we should maybe think about how amazing it is to have a cup of coffee with made of water, made of a plant that was a flowering plant which developed about 140 million years ago. Not coffee, but later. Coffee came later, but the flowering plants came about 140 million years ago. That was a revolution. That changed the world. That's where all the plants that we see around us, practically, except for pine trees and things like that, all the other plants are flowering plants. Even the grass is a flowering plant. And the grass is so important. The grass feeds animals. The grass makes wheat, right? Wheat is a grass. Rye, oats, corn, rice, all the things that we eat are from flowering plants. And without that, what would we eat? Pine cones, you know. Not pine cones, but the seeds. What would you have to eat? Um, so it looks like one thing follows another in the world. Getting hard to sit, huh? All right, thank you for being in class, Lily. Thank you. Thank you for being in class. I appreciate it. Arigato. So is everybody leaving now? All right. We're almost finished anyway. Let's see. I guess I'm gonna end it here.
Okay, Barry.
Thank you for attending today, Frank. Appreciate it.